Hi and welcome to the On Maths prediction for the higher tier legacy Edexcel paper. This is filmed after paper 1. Enjoy! Okay, so this is a prediction for the RESIT paper, the legacy paper. So if you're in year 11, this is not the paper you're going to be doing. This is only for year 12 upwards. So it's the last chance to have a go at doing the legacy paper, the one that's since 2010, I think the last time it was changed. Now, how these predictions are made, well, I've taken off all the topics from paper 1, and I've looked at the remaining topics and sort of cherry-picked the most frequent ones that tend to come up. And also, if they ask that topic on paper 1, they'll probably ask that topic on paper 2. It is a bit of statistics, but it's also a bit of guesswork as well. So don't solely rely on these predictions. Use this as a revision tool as part of your general revision. Now, the way this works is I go through the paper, which is on onmaths.com, and what the benefit of doing it online is that the numbers change each time. So you have a completely different question, well, the same question with completely different numbers each time. Therefore, you're remembering methods and not just answers, not like, oh, that one's 20, so I'll just write 20, fine. Also, the onmaths.com will give you a grade, and also if you log in, it will save your scores so that next time you have a go, you can see an improvement. So what I'm doing now is just going through the paper for one set of numbers, and hopefully it will explain how to do each of the questions. I hope you enjoy it. Let's get started. Instead of going straight to percentages for this question, I would first of all get it as a fraction. So it says there's 15 students who are female and 31 altogether. So the fraction is going to be 15 over 31. And to simply convert between fractions and percentages, all you need to do is times by 100. And percent means per 100, so it's always going to be times by 100, and that'll always give you a percentage. So I'm going to get my calculator out. Now I can write that as a fraction, or I could do 15 divided by 31. It gives you the same answer. So 15 over 31 times by 100. And it gives me a fraction, so I'm going to press S to D. And it's 48.3870 blah blah blah, and it says give it to the nearest percent, so that's a 3, so it's not going to move that 8 up to a 9, so it's just 48%. When solving, always just write out the question and put down lines either side of the equals. And what we're looking at doing is doing something to both sides so that we get x on its own. So we want to end up with x equals at the bottom. That's when we know we've solved it. So looking at the left hand side, we need to get rid of this 6 here and the takeaway 6 there. Now we must remove the plus or the minus first, as long as it's not trapped in a bracket or a fraction. So we're going to get rid of the minus 6. To do that, we need to do the opposite of it. So we need to add 6 to both sides. So we're going to end up with 6x on the left hand side, because we've got rid of the minus 6. And we're going to add 6 to that to make 60. Now we want to get rid of the 6 before the x. Now that's a times 6. When you put a number next to a letter, it's a times. So to get rid of it, we need to divide 6. So we're going to end up with x on the left hand side, and 60 divided by 6 is 10. So the answer is x equals 10. Didn't need that much room in the end, and that's it. When you're asked to do a plan or a front or side elevation, it's important to remember that the diagram you're going to be drawing must be absolutely square on. So there's not going to be any 3D lines at all. It's just going to be 2D shapes like rectangles. Sometimes you have triangles. Occasionally you might get a circle or a semicircle. So let's have a think. What does plan mean? Plan means view from the top. So what of this shape are we going to see from the top? Well, we're definitely going to see this one. But we'll also see this one as well. Now we've got to work out what the sizes of them are going to be. Well, the top one's easy. It's just 7 centimeters by 6 centimeters. Now I'm not going to be able to draw this accurately because I don't have a ruler, but we can almost get it right. We can get it kind of right. And if I label it, that's going to be 7 centimeters, and that should be 6 centimeters. And in your exam, just make sure you actually measure them, because they are said to you in here, and it does say accurately construct, so you want to make sure that it's done 7 centimeters and 6 centimeters. Now, the difficulty is going to be the last bit. Well, we know it's going to be 6 across because it's the same as this one here, but what's the width going to be? What's this one going to be here? Well, if this one here is 7 and this one here is 9, what's left over? Well, there's 2 centimeters left over. So it's going to be 2 centimeters in width. Ooh. Let's use this one, right. So it's going to be 2 centimeters in width. So 2 centimeters there. And this one obviously is going to be 6 centimeters, the same as the right hand one. Now this line we have in the middle, this line here, is really important, because that shows that there's a join, that there's something happening there. So you need to construct, you need to show that, especially if there's a change in elevation, just show it with a line on the diagram. Okay, so this is quite a tricky question because it mixes fractions and ratios together, but we've got to be comfortable with that. So I'd first of all just show the information so that I can get my head around it. So we've got Denver, who as a fraction has 3/19 of the food. And so that leaves how much? Well, we've got a calculator, so we could just do 1 take away 3/19 on the calculator, but we know that that's going to be 16/19. So we can kind of ignore Denver now, because we used Denver's amount, or fraction of the food, to work out Engel's and Fido's combined. So that's how much food they'll get, but they're sharing it in the ratio of 5:2. So in total, the amount of parts they have is 5 plus 2, which is 7. So there's 7 parts altogether. Okay, and each part, so one part, is going to be worth, well, as a fraction, it's 16/19 divided by 7. So 16/19 on the calculator divided by 7, which gives us 16/133. So that's the fraction of each part. Now it says, show what is Fido's share. So we're looking for Fido's share. Now Fido gets 2 lots of that. So looking for Fido, he gets 2 lots of that fraction. So I'm going to times that by 2 on the calculator, which is 32/133. Now it does say show your answer as a percentage rounded to the nearest percent. So to work between fractions and percentages, I just need to times by 100. So what I can do is just times that by 100. I'll do it on the calculator, times by 100, and press S to D if it comes up as a fraction, and it says 24.060 blah blah blah. So to the nearest percent, Fido gets 24%. With two-way tables, we've got to use the totals to work out the missing numbers. So a nice place to start is this box here. If we have a look, we've got a total of 46 people with brown eyes. 23 of them are female. So all you need to do is 46 and take away the 23, and that leaves 23 left over. Now let's have a look at a nice easy one. Right, green eyes, that's a nice easy one there. We've got 48 in total, and 27 females with green eyes. So we want to do 48, take away 27, and that leaves us with 21. Now if we have a look at this one, we have 23 females 23 males with brown eyes, 18 males with blue eyes, and 21 males with green eyes. And we assume that there weren't any others because they're not in the table. So we add those together and that gives us 62 in total. And let's have a look at this one maybe. So we've got 62 females altogether, and we've got 27 of them have green eyes and 23 of them have brown eyes. So we take the 23 and the 27 away from 62, and that leaves us with 12. And we can just check that. We can do 23 plus 12 plus 27 and it equals 62. So we know that's right. With that one sorted, we can get this one. And if there's 18 males with blue eyes and 12 females with blue eyes, that means there's going to be 30 altogether. Now this total is either the total of these ones or the total of these ones, and they should give you the same number. Don't add the blue and the green ones together, so it's only one of them. So 46 plus 30 plus 48 is 124. And let's just check that. 62 plus 62 is also 124. So don't ever write down 248 because that's not correct. So in total there are 124 people whose eye colour were checked. So we're told 1 kilogram of cheese costs £7.70. How much would 600 grams cost? Well, first of all, I'm going to have weight, mass, and price, and I'm just going to sort of split them down the middle. So the weight, well, 1 kilogram is not going to help us because this one's in grams, so I'm going to convert that to grams. So it's 1,000 grams, and I'm going to convert this into pence, so 770 pence. Okay, so I need to get to 600 grams. And so first of all, if I've got a calculator, I can do this a lot easier, but without a calculator, let's try. Well, I can first of all divide this by 10 to get it so that it's 100. So that's 100 grams, and that would be 77. And then what I can do is I can times these by 6 to get 600. Okay, so if you've got a calculator you can just type it in, but let's assume that you don't for this question. So we've got 77 times 6. 6 times 7 is 42, add a 0, 6 times 7 is 42, add them together. Probably don't need to do this, but anyway, I'll do it anyway. 264. So it's 462 pence. But in pounds it would be £4.62. Last thing, just check it makes sense. Well, we've got just over half, so therefore the price is just over half, so it looks good to me. It's important that we're comfortable with converting between ratios and fractions. So having a look at this question, there's red on the first one is 8 and blue is 17. So for every 8 red there are 17 blue, and it's asked us for the fraction that are blue. So there are 17 blue, so 17 goes at the top of the fraction, but how many are there all together? And so it's tempting to put 17 over 8, but it's all together. The bottom of a fraction is the total, so we need to do 8 plus 17, which is 25. So the fraction is going to be 17 over 25. Okay, the next one asks us to work the other way. So we've got green to black counters, and there's that fraction that are black. So there's a couple of ways of doing this. I could write down them as fractions actually, so why don't I try that? So we know that there are 4/7 that are black, and we know that there are only green and black, so there must be 3/7 that are green, because it has to add up to 7 over 7, which is 1. So looking at that, what we can do to both sides, and I can put little lines down here, I can times both sides by 7 to simplify the fraction, to simplify the ratio even. So when I times the left by 7, I get 3, And when I times the right by 7, I get 4. So the ratio of green to black, and be careful that you have it in the same order, so we needed to have green then black, is 3 to 4. And make sure that it's in simplest form, which it is. So we're given quite a basic diagram. We're given a pair of parallel lines and we're given 2 angles from them. And angles on the parallel lines, there are 4 things you should be thinking about. So the first one is corresponding, those are F angles. The next one is alternate, which are Z angles. The next one has loads of names. It's co-interior, interior, allied, whichever your teacher says. And the last one is vertically opposite. Now, vertically opposite occur in other places as well, not just parallel lines, but that's normally the one that you will be using. So let's have a look. Well, what letter does that make? So if I draw out from the parallel lines, I always say it's the armpits of the letter. So if it's a Z, it's the armpits of the Z. And if it's an F, it's the armpits of the F. Well, this is like an upside down backwards F. So we know that upside down backwards F, any F angles are going to be the same. So I know that's 62 degrees. Now we've got to give a reason. So the reason is corresponding. Now I always got corresponding and alternate mixed up. So I don't know whether this will help you, but I always think cor F ponding and alternate. Please don't spell it that way, but I just literally bung the letter into the word and I've never got them muddled up since. So that might help you. The other one, the C angle, are not equal. So these ones here are not equal. They add up to 180 degrees. So just be careful with that. The rule of thumb is if you're guessing and they look the same, even if it says it's not drawn to scale, if they look the same, then if you have no other memory of what they're likely to be, if you forget about angles on parallel lines, just write down the same angle. If the one's acute and one's obtuse, just take it away from 180 degrees and maybe you'll get some marks. But hopefully you'll remember the corresponding alternate, co-interior or interior or allied, and vertically opposite. So you'll need a calculator for this question. The different calculators do things slightly different, but by far the most common calculator, and if you haven't got one, I would recommend them, are the Casio calculators. Mine has a shiny solar panel on the top, but you don't need that. The average battery life lasts way longer than you'll ever need the calculator. So the first button I would press, and there's different ways of doing this question, is the button to get the fraction, which on the Casios looks like this. And that will make a fraction appear on your calculator. Now, some of the older ones, the fraction looks a bit weird. It involves like a symbol like this. And actually on the new ones it can, but you need to change the settings if it does that. It should open up, it should look something like this, like a box and then another box, and there should be a cursor blinking in this box. Okay, so we want to fill in this top box first, since it's already flashing. So 76.8 plus 81.9. Okay, and so to shift downwards on the Casio calculators, there's a sort of cursor, like a cursor stick, a direction button thing. It's the big blue button beneath the screen on most of the calculators, and you just push the down to go to the denominator of the fraction. And then we need to fill in this bit here, so 0.19. And then to get the squared button, it's on like that. So you just press that and it looks exactly as it does in the question on the screen, so you know you've got it right. So you press the equals, and my one comes up with 4396.121884. Now, it might be tempting to try and round that, but it says it wants all the figures, so just put them all in. Now, if your calculator is set to a mode which it's going to show even more numbers, then normally six digits after the decimal point is more than enough. They won't require you to go to 100 or 200 decimal places. On this question, that's actually an exact amount. Okay, so write down correct to two significant figures. Now, to do two significant figures, we start counting at the start of the number. So I'm going to do a red line where you need to start counting. And you just count 1, 2 numbers. So the blue line is where I've stopped counting. Now, all of these numbers here are going to be reset to 0. They're going to go away. Well, not quite. Let's come to that later. Now, this number here, the 9, is what we call a decider number. Now, that number is going to go. That 9 is gone. Okay? But before it goes, we need to see whether that is 5 or more or 4 or less. If it's 5 or more, it pushes that 3 up to a 4. So the answer will be 4, 4, and then you'd think, oh, okay, that's it, rounded, and you'd write that in your answer column. But when I said they disappear, they don't quite disappear. All the numbers above the green line that I've just drawn reset to 0. They turn to 0. Now, if you think about it, if I don't know what would have a decimal place, but if you have a number 4,396.121884 written down, and someone says, "Can you tell me roughly how much that is?" Then if you say the answer of 44, that's not roughly 44. It's nowhere near 44. So the 9 and the 6 will turn to 0, and actually the other numbers do too. But these numbers here are not changing the number at all. These 2 zeros here will make that 4,400 instead of just 44. The other numbers after decimal point, we might as well get rid of them. So the answer is 4,400, okay, because we don't need to show these numbers. Now, the reason students make this mistake is they're so used to decimal places. Now, decimal places, you always remove them because they're always after the decimal point. But with significant figures, they need to turn to zeros. Okay, so we've got a scatter graph question, and the first question asks us just to plot the information from the table into the scatter graph. So we've got ice cream sales at the top and temperature at the bottom, which is not kind of the same way around as on the graph, so we've just got to be careful. So the ice cream sales are 46, which is here on the scale, and the temperature is 31, which is here on the scale. And just check that you're looking at the scale correctly. So we're looking about, let's have a look, about here. Okay, next one, ice cream sales 40, which is here on the scale, and temperature 34, which is here. So we've just got to be careful, and it's about there. So those are the two plots that we want to take. Next question says, on another day had an average temperature of 45 degrees. Use the scatter graph to estimate the sales of the day. Now, you need to get used to just drawing a line of best fit to any scatter graph that you come across. You will have to do it, okay? So just do it. Just, even if it doesn't ask you to, just draw a line of best fit. Now, a line of best fit is just a line that follows all the data like that. You should have roughly the same amount of data top and bottom, but it doesn't matter if it's not perfect, okay? So let's have a look. So we've got average temperature of 45 degrees. So we're going to draw a line up from 45 degrees, which is about there. And we're going to draw, oh, the line didn't come up. So let's draw that line there. It's refusing to come up for some reason. Let's try another one. There we go. Let's try another line. Okay, let's do it the old-fashioned way. Okay, and then we draw a line across from where it's the line of best fit. Now, to me, that looks like about 55. But if you had the same question and you came up with a different answer of 54 or 58, it still can be correct because you might have drawn a slightly different line of best fit. Okay, so don't worry if you sit down next to someone, do the same question and get a slightly different answer. Just draw the lines, straight lines, unlike mine, onto your diagram to show the examiner that you worked it out. So we've got 55 sales we're predicting. Now, what do we notice about this? Well, look at where all the data is. All the data is here, and yet we're estimating outside the range of the data. Okay, it's called extrapolation, where you do that. So the problem with that, if you imagine we do a graph of height against age, so we have age at the bottom and height up the side, then when you're very young, you grow quite quickly. And if someone extrapolated your data and said, oh, okay, well that growth is going to continue, when you're 80 years old, you're going to be 20 foot high. Well, that doesn't make much sense. It's because we're quite confident with down here, because we've got data for that, but we're not very confident with this bit here. We don't know whether the trend continues. Now with ice cream sales, if it's ridiculously hot, no one's going to leave their house. They're all going to be sitting inside with their air conditioning, or sitting in their car with their air conditioning. So we know it probably won't continue. So if you just say that the estimate is outside the range of the data, and if you want to really impress the examiner, then you can use the word extrapolated. It's been extrapolated. Okay, so this question's about an adult and two children. So we've got David Smith and two children. So there's one adult and two children. But the prices shown are not quite right, because there's a discount. There's a 5th off adult price and 30% off the child price. So let's work out the adult price first. So a 5th off. Well, first of all, let's work out a 5th of £70. So to work out a 5th, you can just divide 70 by 5. Now I know that 10 fives are 50 and 4 fives are 20, so that's going to be 14. So that's going to be £14 he gets off. So therefore the price will be the £70 take away the £14. So 70 take away 10 is 60, take away 4 is 56. So he's going to pay £56 himself. Let's do the child price. Okay, so it's 30% off the child price. So we want to do 30% of £37. Okay, let's do the equals down here to give us some room. Well, I know that 10% is going to be £3.70, and then I need to times that by 3. Okay, so I could just times it by 3. Let's have a think. I could do 370. I could do it in pence, and then just times that by 3. So 370, and then I can just do times 3. So I can do a little grid. And if this is on the calculator, then obviously you just type it into the calculator. And obviously that's going to be 0, so we don't need that one. So it's 900, that's 21 with a 0. So 900 plus 21, 210 even, 0, 1, and then 11. So that's going to be £11.10. And so we want to work out the price. So it's going to be £37, take away £11.10. So if you take away 10 it's 27, take away 1 is 26, take away 10 is £25.90. Now that's for one child, so that's one child. So if I want two children, I want to do £25.90 times 2. Now I know 25 times 2 is 50, 90 times 2 is £1.80, so that's going to be £51.80. Okay, I'll move down a bit, and let's do the total. So the total is going to be the adult price, which is this one here, plus the 2 children price, which is that one there. So I want to do 56 plus £51.80. And again, if you've got a calculator, you can just type it in, but let's do the column method. £1.80, and then people like putting the zeros in. So that's going to be 0, 8, 7, 10. So that's going to be £107.80. So it's £107.80. Finished. Okay, there's more than one way to expand and simplify a single bracket. You're essentially doing the same thing, but some of you might want to draw grids or do it in a different way. I always just use smiles and rainbows, so I just create a smile between the 2 and the 3x, and a rainbow between the 2 and the 6, and I put a little time sign there to remind me to times it. Just put a notch through the bracket. That means we're going to times 2 and 3x, and 2 times 3 is 6. And then we've got the x there, and 2 times 6 we're going to times together to make 12. Now we've still got the 4x, so I still need to write that down. Then I'm going to collect like terms. Now the like terms we have is the 6x and the plus 4x. So 6x plus 4x is 10x, and then there's nothing that we can do with the 12, so we just leave that. So it's 10x plus 12. Okay, the next one, there's a double smiles and rainbows. We've got one here, bit old time sign there, and we've got one here. So we'll do the first one first. So 8 times 6x, so we do 8 times 6, which is 48, and then we've got the x. Then we do 8 times positive 2, which is 16, so plus 16. Now that's nice and easy. However, the next one's slightly different. The number outside the brackets is not a 3, it's a minus 3. So when we do minus 3 times positive 4x, we're going to get a negative, because a minus times a positive is a negative. Then we do 3 times 4, which is 12, and then we've got the x as well. Now the rainbow is minus 3 times minus 5. 2 minuses times together is a plus. 3 times 5 is 15. Then we look for like terms, so we've got the 48x and the minus 12x, and we've got the plus 16 and the plus 15. So we want to do 48 take away 12, or 48x take away 12x. So if we take away 2 it's 6, if we take away 10 it's 36x. Then we want to do 16 plus 15. Well, 15 plus 15 is 30, so that's going to be 31. So the answer is going to be 36x plus 31. Now the most common mistakes are for that n bit there, this bit here. Sometimes students will write down negative 15. Now, this is quite an unusual question because it's asking us to find the mean from a bar line graph. Now, what I would do is I'd first of all just start drawing a table for this information, because I'm used to finding the mean from a table, so that's what I'm going to do. And so we've got pets, we've got the frequency, and we'll worry about the last column in a second. So 0 pets, the frequency is 6, 1 pet, the frequency is 10, 2 pets, the frequency is 6, 3 pets, the frequency is 6, and 4 pets, the frequency is 1. Now to find the mean you add an fx column, and I always call this, whatever is here, x, and I always call the frequency f, so it's the fx column, and you just times them together. So it's just a way of finding out those 6 that were 0, well how many is that in total? Well that's going to be 0. Those 10 that had 1 pet, how many pets is that in total? 10. Those 6 people who had 2 pets, well how many pets are there in total? Well 2 times 6, which is 12. there were 6 people with 3 pets, so that's 18 pets altogether, and there was 1 person with 4 pets, so that's 4 altogether. Then what you want to do is you want to add up the fx column, and we do that with a little e symbol, just means sum of. So I'm going to do that on the calculator now. So 0 plus 10 plus 12 plus 18 plus 4, which is 44. You also want to add up the frequency column, so sum of frequency. So it sometimes tells you in the question how many there are, so just double check that. So I'm going to add those together, so that's 29. Now, the mean is all of this stuff added together over how many there are. So you kind of want to swap these over. Okay, so it's 44 over, which means divide, 29. So 44 divided by 29. And it comes up with a fraction on the calculator, so just press S to D. And that equals 1.5172 blah blah blah. It asks for 2 decimal places, so to 2 decimal places that is 1.52, because that 7 moves that 1 up. The important thing to remember with an estimate question is that you don't get any marks for getting the exact answer. So even if this does come up on a calculator paper, then you won't get any marks for getting the right answer. It wants you to estimate. Normally, that means to round everything to one significant figure. Now, there are some exceptions to that. Square roots are an obvious one. If you've got root 82, you won't make that, I should put squiggle lines, you won't make that root 80, you'd make that root 81, because then you'd be able to say, well, that's roughly 9. Anyway, there are some small other exceptions. So let's go through this and let's convert these all to one significant figure. And if I draw some lines in, then that might help me. The line for the first one will be between the 7 and the 3, so that will just be 7. For the next one, the line will be after the 1, so that would be 200. Ooh, switch that back. Get all in the same colour, so that would be 200. Now this is where some people make mistakes. They think that that will round to 0, but significant figures ignore any zeros. It's the first non-zero digit you start counting. So the line will go after the 4. So that will round to 0.5. Okay, now we can times the tops together, or times the 2 numbers at the top together. So 7 times 2 is 14, with 2 zeros, over a half. And all we can do here is just times the top and bottom by 2. So I can times 14 by 2 to get 28. So 1400 times 2 is 2800. And the bottom times 2, well, that's just 1. So the answer is just going to be 2800 or 2800. Now the point of estimation is you should be able to do it in your head. You have to write down the working out still, but the point of estimation in real life is when you don't have a calculator. So if you're finding something that you've got to do a little grid or something, or work it out a long way, then chances are you haven't estimated enough. Okay, so this question is a little bit more complicated than it first seems. So we've got Adrian, Ben and Charlie, and then share some sweets in the ratio of 6 to 3 to 8. And it says that Charlie got 12 more sweets than Adrian. Well, first of all, let's have a look and see how many more parts that Charlie... Ooh. Always cross my L's for some reason. Charlie got more than Adrian. Okay, so he got 8 take away 6 is 2. So he got 2 more parts. And so let's have a look and see what one part is worth. So those 2 parts equates to 12 more sweets. So we do 12 divided by 2, 6. So each part is worth 6 sweets. And it says work out the total amount of sweets. So we need to work out how many parts there are in total. So we do 6 plus 3 plus 8. Now I know 6 plus 8 is 14, plus 3 is 17. So we've got 17 parts in total. Each of them is worth 6 sweets. So to work out the amount of sweets, we do 17 times 6. Now we could do 7 times 6, which is 42, 10 times 6, which is 60. So add the two together, it's 102. So there are 102 sweets altogether. So this question looks quite complicated at first, but actually there are two very simple-ish ways of doing it. We've got 2 decagons, and so that means they are 10-sided. And you can just count the sides if you want, but you know, if it says it's a decagon, I trust it, it's a decagon. Now what we can do is we could work out the interior angles of the decagons. Well, they'll be the same, so I can just work out 1 and then double it, and then take that away from 360 to work out A. And that's absolutely fine, that'll get you the right answer. A quicker way maybe, and especially on the non-calculator paper, but it works on both papers, is to draw a line up here and realise that you've got 2 exterior angles there. And the beauty of exterior angles for polygons is they always add up to 360. So to work out the exterior angle, always write down what you're working out. All you need to do is 360 divided by the number of sides the regular polygon has, and they have to be regular, otherwise you can't just divide them because we're assuming they're the same. So that's 36. So if that one's 36 degrees there, and that one's 36 degrees there, then all you need to do is 36 times 2. Well, 6 times 2 is 12, 30 times 2 is 6, so that's going to be 72. So let's show the examiner that. 36 times 2 equals 72 degrees. Okay, so tree diagram question, and this one says that in bag 1 there are 3 blue counters and 4 red counters, and in bag 2 there are 4 blue counters and 3 red counters. So with tree diagrams we always start here and we ask ourselves, well, in bag 1 we can either pick a blue or a red. Well, let's start with blue. What's the probability I pick a blue? Well, there's 3 blues and there are 3 blues and 4 reds, so 7 in total. So we move on. We've picked a blue from bag 1, so we're currently here, and we look at bag 2. Well, in bag 2 there are 4 blue counters and 7 in total. Let's go back a little bit. Let's go back to if we picked a blue in bag 1. Well, we could have picked a red in bag 2. So there are 3 reds and 7 blues. Now let's go all the way back to the start and let's pretend we picked a red from bag 1. Let's have a think. What's the probability? Well, there's 4 red and 7 in total. And a blue from bag 2, well, that would stay the same, wouldn't it? Because there's still 4 blues and there's still 7 altogether. And there's 3 reds and 7 altogether. And that would be enough to get you full marks. Let's move on to the second question. It says work out the probability that 2 counters picked are of different colours. So let's follow the paths down. If I pick this one, so a blue and then a blue, I've ended up with a blue and a blue. Well, they're not different colours. So let's try another line. So if I pick a blue and then a red, well, that's a blue and then a red. So we want that one. Let's start going down here. So I pick a red from bag 1 and then a blue from bag 2. Well, that's the one we want. And let's try the last one. So a red from bag 1 and a red from bag 2. Well, they're not different colours. So it's these middle 2 we're interested in. It's that one and that one. Now the way of working out the probability of ending on either of those is just to write down the fractions that you passed to get there. So I passed this one, so 3 over 7, and I passed this one, so another 3 over 7. And then what you do is you times them. Now to times fractions you just times the tops times the bottoms. So 3 times 3 is 9, 7 times 7 is 49. Let's do the same with the red and then blue. So we passed a 4 over 7, and we passed another 4 over 7. And let's times them. So that's going to be 16 over 49. Now this is the problem, is we end up with two fractions. Well, we need one answer, so we need to find some way of combining those together. And in probability we use the word or. It can either be that one or that one. And any time you use the word or, what you're going to do with the fractions is just add them together. Now the beauty of this is normally you're going to end up with lovely denominators that are the same. And when the denominators are the same, all you need to do is add the numerators. So 9 plus 16 is 25, and the bottom stays the same. So it's 25 over 49. Whenever we see a 3D shape in a question, you've got to ask yourself, is the question asking for a volume or a surface area? And that should be the first question that goes into your mind. Yes, it might be asking for something else, but those are the main two. We're looking at this, we're filling the swimming pool with water, so it's going to be a volume question. Now, way of approaching this is figure out what the shape is. Well, the shape is a trapezium-based prism. So we've got to first of all work out what the area of the trapezium is. So I'm going to draw the trapezium out first. And that height is going to be 2.7 that side, 5.3 that side, and 25 across. And I'll leave off meters because I know they're all in meters, but do check they are all in meters when you do this. So we've got to first of all work out the area. Now the area of a trapezium is half A plus B H. Now A and B are always the two parallel sides, and then the height is the one that connects them at right angles. So the height is going to be 25 there. And all you're doing is working out the average of the two bases, the 2.7 and the 5.3. We're going to times that by 25. Okay, so we'll crack our calculator out. 2.7. Some of you will probably see this straight away. So the first bit comes out as 4, because halfway between 2.7 and 5.3 is 4, and then times 25 is going to be 100. So the area is 100 meters squared. Now, for a prism, so volume, all you need to do is work out the area of the cross section, which is this bit here, the bit we just worked out, and then times it by how 3D it is. I think they call that the length officially, 15 meters. So the volume is going to be 100 meters squared times 15, which is going to be 1,500 meters cubed. So that's what the volume is, and it says the machine transports the water at a rate of 20 meters cubed per minute. So in 1 minute it's going to be 20, in 2 minutes 40. The other way of working this out, or the other way of thinking about this, is how many 20s are there in 1,500? So we can say time equals, so this is how much it's got to fill, and this is how much it does per minute. So on the calculator, 1,500 divided by 20, which equals 75 minutes. So it's going to take 75 minutes to fill the pool. Okay, so for this question we need to work out the length of the arc, which is around here, and then we need to work out what this and this are. So we're going to do arc first. I'm going to show the examiner that I'm doing the arc first. Now the distance of the arc is the total circumference of the circle times by the fraction of the circle we've got. So you want to work out what the fraction is of the circle and times it by the circumference of the circle. So to work out the fraction of the circle we've got, well, we've got 146 degrees and there are 360 degrees in total in a circle. The formula for the circumference of the total circle is pi d, or 2 pi r. Well, here we've got a radius because it's halfway across the circle. If you imagine the whole circle looks something like that, then the 37 is the radius. So we need to first of all double the radius to get the diameter, and so we're going to do pi times 74, which is twice 37. Okay, so we type that all into our calculator, so I press the fraction button, 146 over 360 times pi times 74. And it gives me in terms of pi. I don't need it in terms of pi, I just need it as a decimal. So 94.2826 blah blah blah. Now that's for the arc length, but we also want to know what this distance here is. Well, we've already got that one. And what this distance here is. Well, they are both radiuses, or radii we call it. So that's also going to be 37 meters. So to work out the perimeter, I'm just going to get that 94.2826 blah blah blah, and I'm going to keep it in my calculator. And I'm going to add 37 and add another lot of 37. So add 37, add 37, and that gives me 168.2826 blah blah blah. Once it's two decimal places, so line goes down here and we've got 168.28. Now just be careful that you add on the extra bits. When it asks you for a perimeter, just make sure you've gone the total distance around the shape. Put a dot and just draw with your finger around the shape to make sure you've got all the distances. Okay, so question A is about reverse percentages. So in 2014 and 2015, well, let's have a look. So the sales went down between the two. So if we start off with 100% and they went down 12%, what we're left with? Well, we're left with 88%. Now, as a multiplier, and this is the best way of doing this, 88% divided by 100, make it a decimal, is 0.88. Now that number, 0.88, is what we times the 2014 sales to get 2015. But in this question we're given the 2015 sales, so we're given this one here. So we want to work backwards. So what we want to do is I'll get my calculator, 7,359 divided by 0.88, and that gives me £8,362.50. You've got to ask yourself, well, is that reasonable? Well, they went down by 12%, so it's natural that they would go from a number around just over 8,000 to a number that's just over 7,000. So I'm going to write the answer, £8,362.50. Okay, the next question says that the sales went up in 2016, or they have a target to get their sales up in 2016. What's the percentage increase? Now percentage increase or percentage decrease, it's the same formula, is change over original times 100. So the change, well, that's going to be 12272, take away the 2015 sales, so that's that one there, 7359. So they're looking for it to change by 4,913. The original was at 7,359, then we need to times by 100. So I'm going to divide that by 7359, times it by 100. And that gives me 66.7617 blah blah blah. So that's to the nearest percent, so that's going to be 67%. Okay, so this question, it looks like a standard bearings question, but something you might notice is there's no angles in it. So if there's no angles in it, we need something else, and that something else is going to involve the right angled triangle here. So we can see there's a right angled triangle here, and we know that when we've got right angled triangle, we've got two sides, we can find an angle with trigonometry. I'm going to call this angle x. Now to find x, we need trigonometry, and to do trigonometry, we need to label the sides. So we've got the opposite here, which is opposite the angle we want. We've got the adjacent here, and we've got the hypotenuse here. Well, the hypotenuse is no interest. We're not looking for it, and we're not given it. So it's O and A. So writing SOHCAHTOA, SOHCAHTOA. Well, we're not interested in the H, so it's not going to be SO, and it's not going to be KA, so it's going to be TOA. So TOA stands for tan x equals opposite over adjacent, and the opposite is 47 and the adjacent is 72. Now we want to work out what x is, so to do that we want to inverse tan both sides. Okay, let's just scroll down. Okay, so on the calculator you want to click shift or the equivalent on your calculator and then tan, and then you press the fraction button, 47, and go down, 72. Just don't forget to close the brackets. Every time you click tan or inverse tan, it opens the set brackets. Just make sure you shut them. Let's press equals, and that equals 33.1356 blah blah blah. Okay, let's have a look. So x is 33, but we still haven't got a bearing. What we can do is work out what this one is, and I'm going to call that y. So to work out what y is, it's going to be 33.1. Well, we're looking for nearest whole number, so let's call that 33. And then we're going to add the right angle here. Now, the reason I know this is a right angle here is because it says that he heads west and then south. So I know that both the angle here and the angle here are going to be right angles, because the angle between all four, north, east, south and west, all four directions are going to be right angles. So I'm going to add 90. And you can do this in the calculator, or you can do it in your head. I'm going to do it on the calculator. 123. Okay, now bearings, something that we've got to remember, are always from north going clockwise. So it's always going to be like that. It's going to be that angle there. So to do that, we're going to do 360. We're going to take away the 123 because that's what we don't want. So on the calculator, 360, take away 123, and that's 237. So the answer is 237 degrees. So there are two things going on here. Varies and inversely are two things you need to look out for. Varies could be is proportional to, or whatever. It could say it that way, or it could just say varies. Now the first thing to write down when it says y varies, or y is proportional to, is do this little fish sign, alpha sign, and that means it's proportional to. Now when it says inversely, it means that it's going to be proportional to 1 over x. The next thing to do is get rid of that fish sign and replace it with an equals. And the way of doing that is just times the right hand side by k, which is a constant. So it's k over x. Now it says when y is 15, x is 14. So we can put those values in to find out what k is. So 15 equals k over 14. And we times both sides by 14 to get k equals. And so we've got 15 times 14, which is 210, equals k. So the formula will be, we sort of go back to this one, the formula will be y equals 210, which is the value of k, over x. The next question says find the value of y when x is 10. So y is going to be 210 over 10. That's nice and easy, that's going to be 21. And then it says find the value of x when y is 6. So we're going to have the equation we've written earlier, so it's going to be 6 equals 210 over x. And what you can do here is you can times both sides by x and then divide both sides by 6. And whenever you've got a one number on this side and a bottom of a fraction, you can actually just switch them over by doing that. So it's x equals 210 over 6. So 210 divided by 6 is going to be 35. What's interesting in this question is there's no amount. So what we can do it in two ways really. You could put an amount in, and it doesn't matter which amount you put in. So normally students go for £100 and then see how long it takes to get to £200, and that's absolutely fine. But you don't need to put amounts in, you can just work with the percentage that you've got. So how are you going to do that? Well, first of all, you've got to convert this percentage into a multiplier. We're going to start off with 100%. Compound interest is money you get, so it's going to increase by 5.8%. So that means that we're going to end up with 105.8%. To make that a multiplier, you just divide it by 100, so it's 1.058. So that is our multiplier. So year 1, our multiplier is going to be 1.058. So 1.058. So we've increased it by 5.8%. To get year 2's, all you need to do is 1.058, which was year 1's multiplier, so after a year, and just times it by 1.058 again. And so I get 1.119364. Well, if you have a look at this bit here, it means it's increased by 11.9%. Well, we're looking to double the money, so we need it to be a 2 point something. So we keep going, and something you can do is you can type in, you can press on the calculator answer times 1.058. And if you press equals, it will give you year 3, which is 1.184 blah blah blah. But all you need to do on the calculator is press equals again, and it will just do the times 1.058 to the previous number. So 1.252, so year 5, 1.325, blah blah blah. So it's going to take a while. 1.40. Let's scroll down a bit. So number 7, 1.48, 8 years, 1.56, 9 years, 1.66, 10 years, 1.75, 11 years, 1.85, 12 years, 1.967, blah blah blah. So we're getting close. And 13 years we get 2.081, blah blah blah. So 13 years is going to be our answer. Now, there's a few things just to note here. The first thing is that students tend to try and divide. They try and see how many 5.8s there are in 100 or whatever. Don't do that, because compound interest grows each time. So in the 5.8%, if you look at the numbers here, these numbers are increasing and increasing each time, and that's the beauty of compound interest. That's why people say save early. Start saving as soon as you're born. The second thing to note is you might be looking at it thinking, really, do mathematicians do that? Do they just have to sit and write them out? Well, no, actually there are other ways of doing it, but at this level, at GCSE, this is the method to do it. Now, there are a couple of different methods for working this question out. What you could do is just draw a line down the middle and split it up into two right-angled triangles, and then use trigonometry to find half of BC and then double it, and that's absolutely fine. I don't ever hesitate when there's a cosine rule to be used, so I'm going to do the cosine rule method, but either one will give you the right answer. So it's an isosceles triangle, so it's 6 centimeters on this side, so we know it's going to be 6 centimeters on this side. And we're given A, well, that's a bit of a hint that it wants you to use cosine rule. And so I'm going to call this one little a, this one little b, and this one little c. So the cosine rule says that it's a squared equals b squared plus c squared minus 2bc cos a. And any capital letters are angles, and any lowercase are always lengths. So a squared is going to be 6 squared plus 6 squared minus 2 times 6 times 6 times cos 100. Okay, and I can just type that into my calculator. So 6 squared plus 6 squared minus 2 times 6 times 6 times cos 100 equals, and so a squared equals 84.502 blah blah blah, and I'm doing the little dashes after the number to show the examiner that I'm keeping it into my calculator. I'm not going to round it. So a is the square root of that, so I might as well just show the examiner that I'm doing that. So I'm square rooting it. So what I'm going to do is just press the square root button on the calculator and then press answer equals, so a equals 9.192 blah blah blah. So to 2 decimal places it's 9.19. To solve a quadratic, first thing you need to do is get it equal to 0. So I'm just going to write it out first of all. And then I'm going to draw my lines down so I can show the examiner what I'm doing. So the first thing I'm going to do is take away 6x both sides. So it's going to be x squared plus 7x minus 14 equals minus 10. And then I'm going to get rid of that minus 10, so I'm going to add 10 to both sides. So it's going to be x squared plus 7x minus 4 equals 0. Now the first thing I do is look at it and go, can I factorise it? Well, given the fact that it wants an answer correct to 2 decimal places, that's a bit of a hint that you're not going to be able to factorise it. Because when you factorise it, you'll normally end up with a much nicer number. And if the coefficient of x squared is 1, you'll end up with an integer. So we're going to have to use the quadratic formula, and there are other methods, but the most common one is the quadratic formula, so that's what I'm going to do. So the quadratic formula says x equals minus b plus minus the square root of b squared minus 4ac over 2a. Now you might say to yourself, well, what is a, b and c? Well, hopefully you don't, because if you're doing this question, I would assume you do know what a, b and c are. But for those of you who don't, a is the number before the x squared, b is the number before the x, and c is the leftover number. Now, the number before the x squared is 1, because there's no number there, so it's 1. the number before the x is 7, and the number on its own is -4, and that's really important that you understand that that's not 4, that's -4. So when I substitute it in, so b was 7, so it's -7 plus minus square root of b squared, well that's going to be 7 squared, so I know that's going to be 49, so I might as well write 49. Now it's -4 times a times c. Now a is just 1, so we can ignore that. -4 times c, which is -4. Well, -4 times -4 is going to be a positive 16 over 2 times 1, which is just 2. Now you could, at this very early point, just type this into the calculator and that would be absolutely fine. Just make sure you put brackets around this and put any negatives in using the special minus button, which on the Casio calculators is 2 spaces above the 7. Okay, let's keep going there. So I might as well just type this in now. Well, I can finish it off. I can do the 49 plus 16 without a calculator. So let's keep going. Let's do it without a calculator for a little bit. So that's going to be square root of 65 over 2. Okay, this plus minus thing here just means that there's going to be a plus answer and a minus answer. So we split it up into 2 at this point. We have x equals -7 plus root 65 over 2, and we have x equals -7 minus root 65 over 2. And what you can do is just type that into your calculator, press the fraction button, then -7 plus root 65 over 2, and then you press equals, and that gives an answer for us. So I'm going to put that straight in, I think. No, I'm going to show the examiner. I know. I'm going to show the examiner. So 0.531128 blah blah blah. And then what you can do is on the Casio calculators you can just use the cursor button, which is the big blue round one, to move across, go to that plus, delete it, and change it for a minus. It saves you having to write the whole thing out again. And then let's have a look. And if yours comes up as a fraction or something, just press the S to D button. It converts it. That's -7.5531128 blah blah blah. Okay, it says to round it to 2 decimal places, does it? Yeah. So we want 0.53. So 0.53. What else? -7.53. So -7.53. There's our answers. There are a few different ways of answering this question. The easiest way, especially for the way this question's set out, is to count the squares. So first of all, let's have a look and see what range we're doing. We're doing from 10, so from 10 to 40. So we need two things. We need to know, first of all, how many big squares, and we might as well count big squares there are between those two, 10 and 40, and we need to know how many there are in total. So let's just have a count: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's 11 tools. So that's going to be 22 in that rectangle. That's going to be 10 high. So that's going to be 10 big squares. 1, 2, 3, 4, 5, 6, 7. So that's going to be 14 big squares. And this little section here is 1, 2, 3, 4, 5, 6. So I can use a calculator if it's on the calculator paper. So let's add those together, and that's going to be 52. So there's 52 in total in that middle region. But we need to know how many big squares there are in total. So we go count the other ones. So 1, 2, so that's going to be 6, so that's going to be 12. And that's the same height, so that's also going to be 12 because it's 6 and 6. So we're going to add the two 12s on. So there's 76 altogether. So total is 76. So it says it wants it to 2 decimal places. So it doesn't want it as a fraction, because as a fraction it's 52 over 76. So 52 divided by 76 is going to be 0.6842 blah blah blah. So that's going to be 0.68 to 2 decimal places. Now what you could have done is worked out the areas of each of the bars to get something that's maybe proportional to the frequency and then done it that way. But if you can count the squares, it's just much easier and quicker. And sometimes you've got to sort of count half squares or little squares and find a way of doing that. But that's absolutely fine. When you're working with proportions, the actual amounts don't matter. This seems like quite a complicated question, but if you break it down into steps, it's much simpler. We need to find out first of all what the area scale factor is. Now it's important that you realise that there is a linear scale factor, an area scale factor and a volume scale factor. To work out the area scale factor, I'm going to get the 1731, which is the new size, and divide it by the old size, which is 2328. So I'm going to get my calculator, and 1731 divided by 2328. And when I do that, I get a horrible decimal. Now you can write it as the fraction that turns up, which is 577 over 776. Or you can write it as decimal, but keep it in your calculator because the next step is to work out what the linear scale factor is. Now there's no linear involved in this, but we need the linear one to then find out what the volume scale factor is. Now to find a linear scale factor from an area scale factor, all you need to do is square root it. So I'm going to square root 577 over 776, or I've just kept it in my calculator, so what I'm going to do is press the square root button and then just answer, which is at the bottom of the calculator, bottom of the Casio calculators. Press equals, and it now gives me a decimal of 0.8622 blah blah blah. And when I do the little dashes at the bottom there, I'm showing the examiner that I'm going to keep it in my calculator. I'm not going to round it. Right, so we need to work out the volume scale factor. Now to find the volume scale factor from the linear scale factor, you just cube it. So I'm going to show the examiner that I'm going to keep it in my calculator, but I'm going to cube it. So what I'm going to do is just press the X with a little square button and then 3, or just press the X cubed button. Let's have a look, and that's going to be 0.6411, and again I'm going to keep it in my calculator because the last step is to find out what the new grams is. Now the reason we need the volume scale factor is grams is a three-dimensional thing, okay, so it's going to be involved in the volume. Yes, with volume normally it's centimeters cubed, but grams works the same way as centimeters cubed. So to work out the new weight, I'm just going to get 319 and I'm going to times it by that 0.641 blah 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 blah. So on my calculator I'm just going to times it by 319, and I get the answer of 204.5322 blah blah blah. It says it wants it to 2 decimal places, so 204.53 is going to be my answer. To simplify a fraction, you need to divide top and bottom by something. So if I just try and divide top and bottom by something now, I need to find something that all 6 terms have in common. Well, there is nothing that all those terms have in common. So the way of starting this is to factorize the top and bottom, so put them into brackets, and then something will turn up. So let's factorize the top. So I know it's going to be x at the start. I need 2 numbers that add together to make 12 times together to make 35. Well, that's going to be 7 and 5. Then I need to factorize the bottom. Now, a little bit of a cheat here. I know one of them will be the same. So either one of them is going to be x plus 7 or one of them is going to be x plus 5. So I need 2 numbers to add together to make the 10x times together to make 21.
Well, I know that 5 doesn't go into 21, but I know 7 does. So x plus 7 and x plus, well, to make the 21 and the 10, needs to be 3. And all you need to do is divide top and bottom by, oh, let's do it top and bottom. Get rid of that. So all I need to do is divide top and bottom by x plus 5, x plus 7 even. And what that does is just gets rid of that and gets rid of that. The fraction stayed the same, but now it's x plus 5 over x plus 3. Okay, so this doesn't seem like the easiest questions because there's 3 shapes going on. There's no numbers in it at all, and we're asked to find a formula. So the first place I'd start is working out, well, first of all, what are the formulas we'll need? Well, let's have a look. So we've got a hemisphere. And some of these formulas you will be given. So a hemisphere is a volume of a sphere and then halved. So instead of 4 over 3, I can just say 2 over 3, which is half of 4 over 3, pi r cubed. The cone that we've got is going to be 1/3 pi r squared h. And then the cylinder we have is the area of the circle times the height. Okay, now we need to find out what the bits are. So for the hemisphere we just need r. Well, that's quite simple because r is just going to be x. It's the radius of the hemisphere. Okay, now what's more difficult is to work out the height of the cone. Well, if the radius across to the right is x, the radius of the circle up is also going to be x. So we know the height of the cone is going to be 4x because one of those x's is used on the hemisphere. We know the radius of the cone is going to be x because it's stated at the top. So let's keep going. The radius of the cylinder is going to be 10x, and the height is just labelled as h. So that's nice and simple. Okay, now let's have a look at what this question's saying. It's saying that this thing here is going to be melted down and is going to be used to create this. So that's just saying that the volumes are going to be the same. So if I add the volume of the hemisphere to the volume of the cone, it should equal the volume of the cylinder. Okay, so we know that hemisphere plus the cone volume, and I should write volume here, show the examiner that I'm working with volumes, equals the volume of, I don't know why I wrote an S, my goodness, C for cylinder. Wow. Tell my maths teacher, right, cylinder, there we go. So hemisphere is 2/3 pi, and we said that x was the radius, so x cubed. Brilliant. So plus the cone. Now, what did we say the height of the cone was? We said the height of the cone was 4x. So it's going to be 1/3 pi x squared, because the radius is x, and is it 4x? Let's double check that. Always double check. Yeah, it is. Okay. So the cylinder, and I'm going to leave that up so I can see it, is pi, and what's the r? So pi times 10x squared, and all of that squared, because all of that is r, times the height, so times h. Okay, so this is the formula we've got to work with. I'll put my lines down. Okay, so what have we got? Let's sort out the timeses first, and let's tidy this up. So that hasn't got any times's in it. This we're timesing it by 4. So it's going to be 4/3 pi, and I'm timesing it by x, so that's going to be x cubed. This one, I'm doing the 10x squared, so I need to square the 10 and the x, so it's going to be 100. And let's do the pi next. Pi, and it's going to be x squared h. Okay. Now, if you notice on the left-hand side, these two here are the same. They're both pi x cubed. So we can just add them together. So it's going to be 2/3 plus 4/3. So that's going to be 6/3, or just 2. So it's going to be 2 pi x cubed equals 100 pi x squared h. Brilliant. Okay. Now let's just check to see what it wants. It wants a formula of h in terms of x. So it wants h equals. Okay. So first thing I need to do, well, let's have a look. What's easy to do? Well, what's easy to do is just divide both sides by pi. Let's get rid of the pi's. So 2x cubed equals 100 x squared h. Now we want h on its own, so we're getting close. We need to divide by the x squared first to get h on its own. So I'm going to divide by x squared. So we get 2x equals 100h. So we can already see we're really close. So to get h on its own, we need to divide both sides by 100. And that's going to be 2x over 100 equals h, or h equals, and we can cancel the 2 and the 100. We can divide them both by 2. Equals x over 50. So our answer is h equals x over 50. Looking at the structure of the answer, it looks very much like we're going to have to complete the square. Now, to complete the square, we need x squared minus something. Okay. Now we've got 2x squared, and so minus something x. We've got 2x squared minus 28x. So we're close to getting that, but we haven't quite got that. So what we need to do is factorize the 2 out first. So 2 brackets x squared minus 14x. And then I'm just going to add the minus 4 at the end. You could also factorize out the 4 as well, but I'm just going to leave that alone because I'll deal with that later. Now that we've got what we need to be able to complete the square, which is the x squared minus something x, we are going to complete the square. Now to complete the square, and I'm going to do this over here to show you a little bit easier. What you need to do is you need to put the x minus half of the bit here, so it's going to be 7 squared. Now that will get, if you expand that, that will be, or using FOIL, that would be x squared minus 7x plus 49. Now we need the x squared, we need the minus 7x to get the minus 14x, but we want to get rid of the plus 49 that it generates. So we need to take away 49 from it. And that's it. That's completing the square. Okay. So I'm going to replace that with what I've just found out that it is, x minus 7 squared minus 49. Now, I have that minus 49 on the inside of the brackets, and I want to collect that with the minus 4 on the outside of the brackets. So I'm going to just expand the big brackets. So I'm going to times the x minus 7 squared by 2. And I'm going to times the minus 49 by 2. And so I can collect the numbers together. So looking at the question, it says it wants m. M is the thing before the brackets, so m is going to be 2. Now it says that p is a positive. Well, we know that p is -7, so I'm going to put -7 there. And q, it says, is a positive. Well, we know it's a negative, so it's going to be -102.
Well, I hope you enjoyed that and I hope you found it informative. Don't forget to go on to onmaths.com and you can do this paper online for completely free. There's also topic busters. Just be a little bit careful that if you look at a topic and go, I've never seen that before in my life, it's probably for the new spec, and a lot of the website is geared towards the new spec, but I've kept all the old topics on there as well, so it should be quite beneficial. Just don't do anything like Venn diagrams or function notation or something like that, because they won't be on your exam. I wish you the very best of luck, and if you enjoyed this video, please click like. If you really enjoyed it and want to see more from us, please click subscribe. Thank you very much.